Okay, guys, let's get started. So the first thing we do here is to create a notebook on Google Colab. And by the way, the first thing you should always consider before you start up on project your hardware components. For me, is the Tesla T4 and tune the distilled BERT model, and that's what you see. Um, I'd already had this provision. I'm simply just adding a new trunk here that um, saves the model artifacts and then lists the artifacts. That's why I'm running it again. Now, while I run the notebook, you'd see that I'm exporting certain files. Now, when I have those files exported, I have to come back into my local directory where I have my Python project and connect to my Hugging Face. Connect to my Hugging Face. Um, Connect to my Hugging Face and then export those model files. So it's as simple as writing a script, and then once I have that script, passing my Hugging Face credentials. Once I have my Hugging Face credentials, I'm just sending the files there. 169 megabytes, so it's quite heavy. Maybe not so heavy, but quite heavy. And these files are not easily saved on GitHub, so you would have an issue passing this to GitHub. So it just makes sense to pass it to Hugging Face. So that's how you start to really think about the machine learning lifecycle. Where are the best places for storage? What are the best places for service? Um, and then how do you connect all of these various components together? So once I have this passed to my Hugging Face model, I can just remove it from my local directory, make my API calls to the model served on Hugging Face, and then make my predictions. Then the next thing, you look through my some of the codes here. As you can see, I'm creating a template for okay, I'm installing some libraries in my requirements file, then creating a YAML file for my GitHub action. Then you'll also see me going to my Docker file and then just running through the steps. So I'm going to install my requirements, create a copy of the application, and then set it in such a way that it can be used or render, deployed there, and then make predictions to the static website on the static website. Now let's talk about MLflow. MLflow is a service for monitoring experiment runs. So for instance, let's say you've got some batch data that you always get, and then you run a prediction service on. What you can do is you can say for every experiment, for every prediction run, you are storing certain metrics. For instance, you're storing accuracy, you're storing the model artifacts. So that's what MLflow does, right? So that is already integrated on Colab because I'm not really doing so many runs. So MLflow isn't so significant here. It's just placed here to show some efficacy. Then we'll want to know about 1DB. That's WANDB, right? It's similar to what MLflow does. It just tracks your metrics and it tracks your experiment run. So when you take my scripts that I run on Colab, you would also see when you start running it, you see an instruction to create a profile on 1DB to monitor the activities done here. So what you're seeing on my screen right now is a tracking of previous and current experiments. I run this before, And the previous run, there's the blue line, while you can see the red line for our current run. So I had done this two more times, and you'd see more runs. You see more happening in your workspace as you continue to run your model, as you continue to train your model on Google Colab. So that's a very good equivalence for model monitoring. Although MLflow promises some form of integratable, permit my language, English, that some integratable service with other technologies. But I feel like OneDB2 has a very good runtime log and then just overall overviews of things. Right. So that the CI/CD YAML file to get familiar with that, but they are easy. All you need is your Hugging Face model ID, which is your username slash the name of the model, your Docker username, your Docker token. You also need to pass and read and write accesses to that token. Then you also need your render service ID and then your render API key. All right. So right now you can see that the tests worked very well. I think I passed in about 3 or 7 tests, and they came out well. One of the tests I passed was to check whether the predicted value, the confidence value for anger, is high for a certain text. The text is actually connotes anger. So I should get a very high value, a high confidence score for that. But I'm also using mock data. And so right now you can see my build and push job to Docker is still running. Hold on. Build and push to Docker, which also runs successfully, pushes about 260 something heavy files. So when you go on your Docker hub, virtually you should be able to see that new repository created, right? So next thing you see here is, so we're done here. Just make sure you note the little things like the name of the repository, the server ID, the token, the rights you want to give to your token. The next thing we're building, or the next service we're using, is render. So you go on render.com and then you create a profile, you link it to your GitHub, then you create a static website. You give it a unique name that must be representative of what you're going to pass in your CI/CD YAML file. Right? You can use a free tier for this. Right? So you can see me making those changes now and then deploying that service. So what ought to happen is when I push again and it creates that Docker image, it passes it to render, and then render can enable inferences. Right? So as it is, we'll finish with the project. I just want to show you what it looks like when you make inferences. So what you need to do is you're connecting to render. Okay. So as you can see, I have the deployed page and then my Python environment. So I'm pasting a post command right to this service here to predict, and I'm saying, what do you think about I am feeling very happy today? What do you think about that sentence? It should give joy, right? But let's see. So I'm making that call onto this service. Okay. So I'm making a change. I'm saying I'm feeling very lonely today, right? So let's see what the predictions will look like. And hey, we see it returns that it's a sad emotion with about 99.825%. Wow. So that's how it works, guys. Fully automated, fully deployed. Anyone can use it. you can go ahead and still fine tune it. This forms a basis or a basic for engineering, especially when it comes to machine learning and artificial intelligence. You can take a very simple context, you can take a very simple exercise like just classifying thoughts and then tuning it on already deployed large language models like a BERT language model, right? You can take it, build on it with your training data and labels. Yeah, you have to tokenize, and you've got to allocate resources carefully and intelligently. Uh, but you can't do stuff, right? You can't then take those models, save it somewhere for anyone to go use and even improve on, and then deploy it as a service. And also put some form of markers, some form of checkpoint before it gets fully deployed by carrying out tests, by building containers, so that you know that within this environment, this should work. So that brings us to the end of this talk. If you've stayed here till now, I really appreciate it. Really just starting on this whole YouTube thing, and I think we'll be seeing a lot of portfolios, a lot of tutorials. But if you've made it up to here, thank you, and please go build something cool today.